Hello students, welcome to the chapter Relations and Functions. This is a lecture number 7 in this chapter. In the previous classes, I have given you the definition of composition of functions and solved some questions on composition of functions. In this video, I am going to teach you the very important type of function, that is invertible function. One of the most important type of function, that is invertible function. Let us see the definition of invertible function. A function f from a to b is said to be invertible if there exists a function g from b to a such that g composition f is equal to identity function on a and f composition g is equal to identity function on the set b, where IA and IB are identity function on the set A and set B respectively. The function g is called the inverse function of f and f is invertible function. Dear students, try to understand. Invertible function means, suppose f from a to b is a function, there exists g function from the set b to the set A. Try to understand. Here a to b is a function and the set reverse b to a, then it is called as inverse of the function f. Inverse of the function f. If I want to explain it through diagram that you can see here, there are sets a and b, non-empty sets you say, capital A and capital B. Set a to b is a function, name it as f. So x is an element in the set A, corresponding element is y, that we call it as f of x. That element is in the set B. Now there exists a function from set B to set A, note it as g function. G is a function from B to A. So here you should write it as, look at the screen carefully, f from a to b implies f of x is equal to y, where x belongs to the set A and y belongs to the set B. Now there exists a function g that is from b to a. This implies g of y that is equal to x. Here also y belongs to the set B and x belongs to the set A. To say the function g is the inverse of the function f, then the condition is f composition g and g composition f both should be equal to identity function. So both if both are equal to identity function, then g is called as inverse of f. Try to understand. If f composition g and g composition f are equal to identity function, then g is called inverse of the function f, and this f is invertible function. If this all story satisfies, then f function is called as invertible function. So this is a formal definition of invertible function, students. Now let me have some examples so that you will understand it clearly. Let f from capital N to capital Y be defined as f of x equal to 4x plus 3, where y is equal to the set small y belongs to capital N such that y equal to 4x plus 3 for some x belongs to capital N. Show that this f is invertible and find the inverse. Show that this function is invertible means I should prove f composition g and g composition f are equal to identity function. How I am going to prove that? Let us see the solution. Dear students, look at the diagram here. F function is from n to y. Here the set n is called domain and the set y is called codomain. Then you can define y is equal to f of x. Remember, x belongs to the capital N, that is a domain. Y belongs to the capital Y, that is codomain. Remember this one very simple point. So taking this all, Let me take y belongs to capital Y, that is codomain, be an arbitrary element. So f of x is equal to y because of the diagram. So f of x is 4x plus 3, that is equal to y. So from here I will find out x, small x I will find out, that is 4x equal to y minus 3, taking 3 to the right side, and x will be definitely y minus 3 divided by 4. Dear students, y belongs to capital Y, x belongs to capital N. So what is the x value here? Y minus 3 divided by 4. This belongs to the domain of the function. For every y belongs to codomain. Now define a function, say g, from reverse I am taking, y to n I am taking. F is a function from n to y, here g is a function from y to n, that is given by g of y. Dear students, g of y is equal to n. Okay, what is the element belongs to the set n here? Just now I told you, is it y minus 3 divided by 4? Yes, therefore g of y is y minus 3 divided by 4. That I am taking here, g of y is y minus 3 by 4. So taking the function f and the function g, let me prove g composition f is equal to identity function, and f composition g is equal to identity function. So these are the things I should consider, and I have to prove this condition. So let me first take f composition g of y. According to the definition of composition in the previous class, clearly we discussed f composition g of y will be definitely, remove the circle, f of g of y. This is the definition of f composition g. So taking this help, I am going to prove this as equal to f of g of y. Substitute g of y, that is y minus 3 by 4, and now f of x is 4x plus 3, but in place of x what we have? Y minus 3 by 4. So in place of x I will write y minus 3 by 4. So simplify, 4 and 4 gets cancelled, and minus 3 plus 3 will get cancelled, and I am going to get is equal to y. So you can observe f composition g of y is equal to y. Is it nothing but f composition g is identity function? Definitely it is an identity function, because f composition g of y is equal to y we got. So f composition g is identity function. Similarly, g composition f of x, according to definition, g of f of x. So now g of f of x, dear students, as you know, g of y is equal to y minus 3 by 4, but in place of y I am going to write the function, that is f of x. Whatever f of x, is it 4x plus 3? Yes. So I am going to replace 4x plus 3 here in place of y. So simplify, plus 3 minus 3 gets cancelled, 4 and 4 gets cancelled, so I remains with x. So you can observe here, g composition f of x is equal to x, then definitely g composition f is identity function. So that I can see here, g composition f is equal to identity function. It means that the f inverse is equal to g function. So f from n to y is a function, g from y to n is a function. This is inverse of f. This is inverse of f, and g is the inverse of f, that we denote it as g equal to f inverse, that is given by what here? F inverse of y, if I say, that is y minus 3 by 4 is the inverse of 4x plus 3 or 4y plus 3. The inverse of 4y plus 3 is y minus 3 by 4. So hence we got a function, the inverse of a function. Let me take one more example so that you will understand clearly. Y equal to n square such that n belongs to capital N is a subset of capital N. Consider f from n to y as f of n is equal to n square. This is a given function, f of n is equal to n square. Show that f is invertible, find the inverse of f, and definitely we should consider the diagram n to y, domain is n, codomain is capital Y, x belongs to capital N, y belongs to capital Y, so y equal to f of x. This is a formal definition of a function. Now let y belongs to, now let n belongs to the capital Y, that is a codomain here, be an arbitrary element. F of n is equal to y. Dear students, here n is the element. The function is defined in the way that is f of n. So I am taking f of n. Don't get confused about f of x and f of n. Whatever they have given, that I am taking f of n. So f of n is equal to y. This implies f of n is n square, that is equal to y. Here I will find out n value, so that n is equal to square root of y. So define a function g from y to n, reverse from n to y, that is y to n, that is given by g of y is equal to square root of y. So this is a function g from y to n. Taking this and all, let me prove f composition g and g composition f are identity functions. So let me take f composition g of y according to definition f of g of y, replace g of y, that is root y, and f of root y. See students, f of n is equal to n square. Now what will be f of root y? Is it definitely root y the whole square? Yes, this only I am going to show you now. So f of root y is equal to root y the whole square, and root and square gets cancelled, that will be y. Hence you proved f composition g is equal to iy. It means identity function on the set y. So go for g composition f of n. So g of f of n, replace f of n students here. So that will be g of n square. So g of n square means how to continue it? Dear students, g of y is equal to root y. Then g of n square you want. Is it nothing but root of n square? Definitely g of n square is root of n square. So that will be, I am writing here, root of n square. Root and square will get cancelled and I left with n. So g composition f is equal to identity function on the set n. So both are identity, f composition g as well g composition f are identity functions. Therefore this g is the inverse of f, that is denoted as f inverse is equal to g. So from these two examples we understood that g composition f is equal to f composition g is equal to identity function, then g is the inverse of f. Try to understand, g is the inverse of f, that we denote g as f inverse. F inverse is nothing but g, g is nothing but f inverse. Only when the condition g composition f, f composition g both are equal to identity function. So after this, taking one more example, if f of x is equal to 4x plus 3 upon 6x minus 4, x is not 2 by 3, show that f composition f of x is equal to x. Then what is the inverse of f? Dear students, f composition f, the definition says f of x. So f of, replace f of x here, given f of x is 4x plus 3 upon 6x minus 4. Now f of x, try to understand students, f of x is 4x plus 3 upon 6x minus 4, right? Now what will be f of 4x plus 3 upon 6x minus 4? In place of x is there a big term, that you have to take in place of x a big term, that is 4x plus 3 upon 6x minus 4 plus 3. 6 into again x, that big term 4x plus 3 upon 6x minus 4 minus 4. So this I am going to show you in this slide now, so that you can observe it carefully. 4 into 4x plus 3 upon 6 into minus 4. In the square bracket I am going to write 4x plus 3 upon 6x minus 4 as I shown you. In the denominator also 4x plus 3 upon 6x minus 4. If you simplify it, you will multiply 4 to the numerator multiply 4 to the numerator. So 4 into 4, 16x plus 12x divided by 16x plus 12 divided by 6x minus 4 plus 3, that I simplify 3 into 6, that is 18x minus 12. The denominator 6x minus 4 will remain as it is, divided by 6 I will multiply to the numerator. So 24x plus 18 minus 24x minus minus plus 16. Dear students, in the denominator actually there will be 6x minus 4. Here also there will be 6x minus 4, but after the cancellation we will not write that one. So only this much. So here plus 12 and minus 12 gets cancelled. 24x and minus 24x gets cancelled in the denominator. The remaining term in the numerator 34x, 16x plus 18x, 34x, 18 plus 16 is 34. So 34 and 34 will get cancelled now. We left with only x. So I proved that f composition f of x is equal to x. Is it nothing but f composition f is an identity function? Definitely this is an identity function. So here, dear students, f composition g is equal to identity function. So g is inverse of f. Hope you know this. Even g composition f is equal to identity function. Again g is the inverse of f. Now I will ask you, f composition f is identity function. So which one is inverse of the function f? F is itself. F is itself the inverse of f. Hagadre f inverse is equal to f itself. The question, what is the inverse of f? The inverse of f is the function itself, that is 4x plus 3 upon 6x minus 4. The inverse of this function is the function itself. So f composition f is identity function and f inverse is equal to f. That only I explained you. Hope you followed this question. So the next discussion is the very important. After understanding invertible function, now we will take inverse of an element. How to find the inverse of an element? The f composition g and g composition f is equal to identity function. Definitely g is the inverse of f. No doubt. Just now we discussed. Is this the only one way to say the invertible function? No, students. There is another way. There is another way also to say the invertible function. So to discuss that another way, let us have a discussion of inverse of an element. Consider a function which is neither 1 1 nor onto. Means the function I am taking now is not 1 1 not onto. Can we define the inverse for entire function? When the function is not 1 1 and not onto, is it possible to say there is an inverse for the given function? That we will discuss now. Consider a equal to 1 2 3 4 5 and the set b a b c d e. These are the two non-empty sets, and the function is defined in a way 1a 2b 3c 4d 5d, and the arrow diagram of this is f function from a to b. 1 is related to a, 2 is related to b, 3 to c, 4 to d, 5 to d. This is a function from a to b. Now define a function from b to a, because we are discussing the inverse. Inverse means reverse. Now I will define a function from where to where? B to a. Hope you are understanding. B to a I will define a function now, that you can see here. B to a. Elements of b, a b c d e. Elements of a 1 2 3 4 5, and this is f inverse. Because it is from b to a, no? So it is definitely reverse of f or inverse of f. So if you think in that inverse, a is related to, you can see and tell me, a is related to 1, b is related to 2, and c is related to 3, d is related to 4, even d is also related to 5. So this function is going to give you the inverse of the function No. The answer is no. Why the answer is no? I'll discuss here, students. So now F inverse we will take it as G. Okay. Now G composition F of X I will find out. G of F of X. Carefully you see this video. G of F of X. Let me take the element 4 I will take, students. Okay. G of F of 4. So here G of, what is F of 4? That is D. Okay. Then G of D. Look at the second function. G of D. Shall I write 4? If I say write 4, if I write 4, then you may think, sir, why not 5? You can see D is related to 4, D is related to 5. So there exist two elements. It means that it is not identity. Hope you are understanding. This is not identity, because identity means what? Same. G of D should get only one element, but unfortunately we are having two elements. Hence the answer for this. Can we define an inverse for this function? The answer is no. Let me take a function which is only 1, 1. Let us try whether the function is invertible or not when it is only 1, 1. Can we define the inverse if the function is 1, 1? Again I will take the sets A and B, and the function is 1A, 2B, 3C, 4D, and A to B, 1A, 2B, 3C, 4D. Dear students, you have a function F in front of you. This function gives the inverse or not? Is F composition G, G composition F are equal to identity? Let us try this. Reverse from B to A to 1. You can observe this and compare the elements. C to 3, D to 4. Dear students, now the question, E is not related to any element. So in this case, is this function gives you the inverse? Is F composition G or G composition F is identity? Let me try. Let me try. G composition F of X is equal to G of F of X. Let me take an element 1. G of F of 1. So G of, what is F of 1? That is A. What is G of A? That is 1. Okay, we got the element G composition F of 1 is equal to 1. Hence it is identity, no doubt. So here identity function we got. Now if I consider F composition G of X, very simple. Now I am going to take the element, which element I can take? E I will take, students. G of E. Dear students, is there the element G of E to write here? There is no element. So it fails. There does not exist F composition G for the element E. Hence again we fail to get. Again the answer is no. No means here the inverse does not exist. Try to understand. Here the inverse does not exist. When the function is only 1, 1 also, the inverse does not exist. Consider the function which is only onto. We have considered the function not 1, 1, not onto. That time also no. We have considered the function is only 1, 1. That time also inverse does not exist. This time I am taking only onto. Can we define the inverse if the function is only onto? Let us take a function from A to B. The function is defined 1A, 2B, 3C, 4C. Function is from A to B, 1A, 2B, 3C and 4C. Clearly this is onto function. And reverse of this, B to A. A is related to 1, B is related to 2, C is related to 3 and C is related to 4. Here students, if I start taking F composition G of X is equal to F of G of X I get. So F of, what is G of X element? X element I will consider as C. So C if I consider. Now the question, G of C F inverse means G only, hope you know that. G of C means which one I should write, whether I should write 3 or 4. If I write 3, there will be a question wrong because some students may write 4. So again it fails to get F composition Z. Therefore here also the answer is no for the question is inverse exist if the function is only on 2. Try to understand. If the function is not 1 1 and not on 2, if the function is only 1 1, if the function is only on 2, for these 3 types of function the answer is no. Means for these type of functions inverse does not exist. Then for which type of function inverse exists? Let us see one more example. 1 2 3 ABC. F is a function 1a, 2b, 3c. F is from a to b. 1 is related to a, 2 is related to b, 3 is related to c. Take its reverse. F inverse from b to a. Here a is related to 1, b to 2, c to 3. So F inverse is nothing but G. We have the function G. So let us start writing G composition F of x is equal to G of F of x. So element in place of x I will take it as 1. So F of 1. So G of, what is F of 1? A. What will be G of A? G of A. G is here, A is here. G of A is 1. Clearly G composition F of 1 is equal to 1. Is this identity? Yes. G composition F of 1, you got 1 only, hence it is identity. Not only 1, even if you take 2 also, you will get the same identity. Even if you take 3 also, you will get the same identity. Here everything gets success, students. Success we get, hence the answer is yes. For what reason the answer is yes? Here the function is 1 1 as well as the function is on 2. You can check. This function is 1 1. 1 1 means, I try to recall, 1 1 is different elements have different images. Therefore it is 1 1. And also this function is on 2. Why it is on 2? Every element of the set B are the images. Therefore this function is 1 1 as well as on 2. That's why we will define the inverse function. That inverse function we will define only when the function is 1 1 and on 2. So note here, if the function is 1 1 and on 2, then it is invertible function. This is another way of saying the function is invertible. So F composition G composition F equal to identity function, and the function is 1 1 and on 2, then it is invertible. Both are the definitions of invertible function. So in this video I discussed the invertible function definition and problems, and the method number 2 also for invertible function, that is the function is 1 1 and on 2. So hope you understood this one. We'll see the invertible functions in detail in the next video, students. Thank you.